Okay, welcome back. I have just two problems that I didn't have time to podcast from the previous lesson. Um, graph the derivative of the function that's graphed over here on the right, so I made it a little bit larger. So these here are the derivatives, and we have to select from them. This is the original function. Well, notice the original function, like here, I'm just going to write some words here. Decreasing, increasing, decreasing, increasing. Here, the tangent line would be the slope of the tangent line 0. Here, slope of the tangent line 0. Here, slope of the tangent line 0. So you have, but decreasing translates to the derivative is negative, and increasing translates to the derivative is positive. So you can see here, below the x-axis, let me see if I can zoom in on that. So the derivative is constantly changing, right? So by process of elimination, it's definitely not this one. And it's definitely not this one because it changes so many times. So we zoom in on this one. So the derivative is negative, below the x-axis, then it hits the x-axis, then it's above. It's above for a certain amount of time, then it hits the x-axis, then it's below for a certain amount of time, hits the x-axis, above for a certain amount of time. So it's appearing to be that. Okay, so just again, the idea that you want to look at the original function and then think about what its derivative would look like. And the last problem, so we only have two for this podcast, is number 47. Let's see. I think this is a question of whether a function is differentiable or not. Yep, that's a good question. So it says, at what domain points does the function appear to be differentiable? So it appears to be differentiable all the way to here, and then not differentiable at that cusp, and then differentiable here. So differentiable everywhere except for at 0. That's a way of saying that one. Then it says, at what domain points does the function appear to be continuous but not differentiable? So here the limit from the left and the limit from the right appear to be approaching the same value, but there's that sharp cusp right there. So it appears to be continuous. We don't see a hole or a jump discontinuity, I should say. But it's not differentiable there at 0. And it says, at what domain points does the function appear to be neither continuous nor differentiable? So I don't see any breaks in continuity. That means, like, if I'm tracing along this with my pencil, I don't have to lift my pencil up. And that's it. So very short podcast for that one.